Hi chums, I'm going to plant some peas, but I've watched people, I'm not mentioning any names, but they just kind of throw the peas in any old fashion and then they complain that their peas don't taste nice or their crop isn't as good. That's because they didn't take the time to do the job properly. So I'm going to show you how to plant peas and how to set them out properly, okay? So here's what we want, okay? We want this idea here, I can just leave it on the table. I think we've got a nice 2 by 2 by 2 equilateral triangles, okay? Now there's a couple of different ways we can get this. What we can do is we can take a set of dividers. Now I've expanded that to 3 inches so it's easier for you to see, and all you do is you set your compass on our dividers on one pea, make an arc, set it in the other, or, well, you can make the arc at the top and bottom at the same time, okay? So you're going to put one on each side and then go here and make another arc, and those 2 points there, that point there and that point there, are 2 inches from each of these peas, because the distance from each pea to the other is 2 inches, so that has to be 2 inches. So anywhere along that arc is 2 inches, and anywhere along this arc is 2 inches, and where they cross over is exactly 2 inches from that pea and that pea, and the same at the top. So you could be lazy and do it that way, okay? And just scribe your arcs and then put a pea there and a pea there, and you know that they are exactly 2 inches from here and here, okay? But it's not very elegant, okay? So I prefer to go a different way about it. What you can do instead is, there's your 2 peas, P1 and P2. I should have actually numbered those for you. And instead of going for 2 inches, you go for a distance that's less than 2 inches, but is more than halfway between each pea. And then what you can do then is, you can make an arc at the bottom and the top, go to this pea and make an arc at the bottom and the top, and then once again where those arcs join, they're exactly the same distance from each pea. So that means that bisects that line, it cuts it perfectly in half. So it means that you've got a line going down the center, but importantly you don't have the distance from the center to the top, to the vertex, to put a pea in position. You have to measure this now. So that's where we come on to the next bit of this. So you've bisected your line, and the next thing we go to is good old fashioned, who said geometry wasn't useful in school? Good old fashioned Pythagoras, right? Pythagoras. So we know from Pythagoras that a squared, the hypotenuse, a squared equals b squared plus c squared. So in this situation we have 1 is the bottom of the triangle, because we know that's halfway, and we know the distance from there to that p is 2 inches. So using those two figures and the b, we can transpose this. Instead of having a squared equals b squared plus c squared, we can bring the b across and leave it as b squared equals a squared minus c squared. So then b squared equals 2 squared minus 1 squared. There's your 2 squared and 1. So that's equal b squared equals 4 minus 1. So b squared equals 3. Now be careful here. Don't be rejoicing because you found what b squared is. That's, remember, to be, you have to find the square root of this. So the square root of 3 is 1.732 inches. So then, whenever you do your bisection, and you bisect this line, you then measure 1.732 inches along that line, and that's where you put your pea. And that distance will then be 2 inches from that and 2 inches from that. Okay? Now, that's one method, but the method I prefer to use is, I think it's a bit more elegant, you know, is using the sine rule. Okay? In any triangle, no matter what the length of the sides or the size of the angles, if you number your triangles at ABC, and then you take the opposite side as A, the opposite side of B as small b, and the opposite side of C as C, then that side over that angle, which is A over the sine of that angle, is the same as that side B over the sine of that angle B, and it's also the same as the sine of C divided by the sine of that C. So it's A divided by the sine of A equals B divided by the sine of B equals C divided by the sine of B. So to put that into context, what we're using, we'll go back to our right angle triangle, and we know that this distance here is 1. We know we're dealing with an equilateral triangle because all the sides are the same, so this angle has to be 60, that angle is 90, so that one has to be 30. Okay, so if we take any two we can use, so we can use A over the sine of A is equal to B over the sine of B. So we don't need this one. So you don't need to use all three. Just any two will do. As long as you've got the figures. As long as you've got three values, you can use any two of them. So using these two, a over the sine of a and b over the sine of b, well then a is 1 over the sine of 30, which is opposite, is equal to b, which we don't know b, over, sorry, where is it? 1 over is equal to b over the opposite angle is 60. So b over the sine of 60. So 1 over the sine of 30 equals b over the sine of 60. So you multiply across with the sine of 60, and that leaves b on its own. So we've got sine of 60 over sine of 30 is equal to b. We don't like working from right to left in mathematics. So if you take that and turn it round, you've got b equals sine of 60 over sine of 30. So everything's running from left to right as it should in mathematics. So then b equals the sine of 60 is 0.886. And the sine of 30 is 0.5, and 0.886 divided by 0.5 is 1.732, which is exactly the same answer as Pythagoras gave us, 1.732. So that's an easy way for you to plant your peas. Alright, so what you do then is you set your two peas out, you bisect your line, which is back here. Where do we bisect? Wherever we bisected our line, and we measure up 1.732 like we did using the Pythagoras method. Okay, so I'm going to head outside here. I'm going to try and turn this into a little bit of a tour because I don't want to move the camera off the tripod because I've got everything set up. So I'll just show you. There's the way the greenhouse is looking at the moment, isn't it? All right. I've got everything fairly well tidied up, but I'll do a proper tour later on. But I'm just going to go out and set this up at the peas and show you how this works in practice. All right. I'm a bit late getting the peas in, as you can. Whoops, tripod's catching and everything. Aren't the onions good? I'm very pleased with the onions this year. Those are one called Centurion that I got from Shelley's Seeds, and I'm very pleased. Shelley's Seeds stuff has been very good. I will definitely use them again. And look, got my grass cut, so I'm happy about that. The mower's fixed, and I just had to put a new deck in. So it cost about £400 fix it, which is a lot less than 2,000 for a new mower. Right, so I'm out here, started putting these in. I'm just going to put the thing down there. And see what I've got there? I've got the peas in a little tub of water. I do that for about 3 or 4 hours before I plant them, because it means that they swell up a wee bit. So I've got my line of peas in 2 inches apart. Now, before we talk over the wind here, I know where the bisector is on that last two at the top there. So I can measure 1.732 inches from there. So that's very simple. You just get your vernier out, okay? And where are we at here? We'll just measure here. Turn it on. Right, need to be careful because you don't want to make. You want to make sure that's in inches. You don't want to do it in millimeters because there's like 1.732 millimeters is virtually nothing, you know. So make sure you're in inches. You're inches. So 1.732 inches. Way up here. 7, 5, 7, 6, 7, 2, 3. There's. We're just missing that. There's 1.731. We'll not fall out over 1 thou. Okay. Although I'll just move the pea a wee fraction to make up for that. And then all you do is I've got my bisectors in position. So you just set that down in the middle there. Then you take your measurement from the center there, again, up to here, and you put a pea there. Isn't that really tidy and neat? So folks, there you are. No excuses for not planting your peas properly. Alright? Right, I'm going to continue with these and then we'll do another video later on. Okay? All the best now. Bye bye.